Planetary nebulae are the most beautiful objects in the night sky. Their gossamer shells of gas are otherworldly and evocative. They captivate the eye, and viewers need no scientific knowledge to get drawn in. How are they created, and why do they look so beautiful? Today we will discuss with you on the topic, why do planetary nebulae look the way they do? Welcome back to Signature's Life, and you're watching Signature's Science. First of all, if we don't know already, planetary nebulae are misnamed. They have nothing to do with the planets, but when astronomers first observed them with their early telescopes, they thought they looked like planets. Now we know different. We know that a planetary nebula is actually layers of gas ejected from a red giant star's outer atmosphere and lit up by the star's radiation. The different colors are from different chemical elements in the gas. But let's start at the beginning. Nebulae begin with stars between about 1 to 8 solar masses. Near the end of the star's life of fusion, the star's gravity weakens as it loses mass. The star expands into a red giant and begins shedding layers of gas from its atmosphere into space. As those layers travel outward, they are ionized by ultraviolet radiation from the star, buried in the middle of all that beauty. That lights up the shells of gas as they travel away from the star, now called a planetary nebula nucleus, or PNN. Planetary nebulae are relatively short-lived phenomena in astronomical terms. They last only a few tens of thousands of years. Our own sun will follow this evolutionary pathway and become a red giant and cast off its own atmosphere to form a planetary nebula. In 2019 and 2020, the Hubble used its Wide Field Camera 3 to image both nebula in their full panchromatic glory. Emission line images from near ultraviolet to near infrared allowed astronomers to study the nebula in detail. These panchromatic studies were the first of their kind. It's all aimed at understanding the nebula formation process and at testing models of binary star-driven nebulae shaping. In a statement, the scientists stated that we are able to see the effect of the dying central star and how it's shedding and shredding its ejected material. We are now seeing where material that the central star has tossed away is being dominated by ionized gas, where it's dominated by cooler dust, and even how the hot gas is being ionized, whether by the star's UV or by collisions caused by its present fast winds. According to this research, the Butterfly Nebula is very young, at about 2,000 years old. One portion of the nebula is even younger. The so-called wings, the S-shaped ion emission features, are not even 2,000 years old. The research also revealed another surprise. What astronomers thought was a central star actually isn't. That one is actually much closer to Earth and isn't associated with the butterfly. Identifying the actual star at the center of it all will require a powerful telescope like that James Webb Space Telescope, and CASNA hopes that the JWST will do just that. Scientists studied various nebulas. The other nebula in this study is the Jewel Bug Nebula, or the NGC 7207. They stated that the Jewel Bug Nebula is based on 25 years of continuous monitoring that dates back to the Hubble telescope's early years. Planetary nebulae are created fairly quickly in astronomical terms. As the red giant star sheds its layers, its stellar winds help shape those layers into the delicate shapes that define planetary nebula. Then, as the star loses its mass, it becomes a planetary nebula nucleus, otherwise the PNN. The wind from the PNN is faster than the wind from the red giant, and it impinges on the gas expelled from the red giant. Those interactions between stellar winds help create the wide variety of shapes on display in planetary nebula. Theory also shows that the shape of the planetary nebula can indicate an unseen binary companion star to the progenitor star. While this presentation didn't present conclusive evidence of a companion, some of the images show that there are poorly understood processes at play that could be related to the binary star scenario. The nebula in the study won't last long. Scientists stated that they are two of the youngest and most rapidly evolving planetary nebula. Their lifespans are short, and as the gases that they are made of continue to travel away from the progenitor star, which will eventually become a white dwarf, they will fade away and dissipate. Those gas will eventually become part of the interstellar medium. In this way, planetary nebulae play an important role in shaping the next generation of stars. The gases from the nebula have a higher metallicity, and the stars that form from those gases will have a higher metallicity. So will any planets that form around any of those stars, and rocky planets like Earth requires metals to form. Planetary nebulae are fascinating, even without all of this detailed knowledge to explain them. In astronomical terms, they are just brief puffs of gas. In the blink of a technological civilization's eye, they are gone.